Welcome to Webinar Wednesday. I am so glad to have you join us. As you can tell from my comments in the chat box, I'm a little bit nervous because this is the first time we've used Zoom and it's a little bit new for me, and there are some features here that I'm not as familiar with, so please give us feedback in the chat box about how this is going for you. Our theme for today is learning about space, and we're going to talk about resources from NASA and beyond that. My name is Sandra Frericks with Click to Science PD, and I'll be your host today. This webinar is being recorded, so you'll be able to come back to it later or share it with colleagues. Our goal today is to learn about how we can use a theme, for example, space, which is what we're going to be focusing on today as an example, but other themes will work as well, to really support youth in engaging in active learning in their after-school and summer programming. Active learning encourages youth to use critical thinking and problem solving. It builds their skills to be college and career ready and supports them in developing a positive STEM identity. So we really want all of these outcomes for the youth in our program. And we're going to focus on how we can use active learning to learn about a faraway topic, space, with resources from a variety of different sources from NASA and beyond. I have a resource that I want to share with you. It'll be a PDF that you can download from the Click to Science website that shows all of these resources and links to them. Great spots that you can go to find resources about this theme of space. Our goal here is really to think about what are the benefits of active learning, what are the benefits particularly of active learning about space. So learning about space can help young people gain a better understanding of our own planet and build their appreciation for this unique place. It can help cultivate their interest and provide meaningful phenomena with experiences that are much bigger than they are. Here are some of my favorite places to go for finding engaging activities about space. In the chat box, if you have other sources that you like to use, I encourage you to share those now, and I can add them to the PDF when we put it up for the recording of the webinar. From the resources listed here, I could plan out a really fun, engaging Space Day event where we spend the whole day exploring issues around space and doing hands-on activities for children or for children and families. I could also make it a week-long theme related to exploring and understanding space, or maybe even a week of engineering new solutions for space. Or if I wanted to, I could find enough resources here to do a whole summer program on the topic of learning about space, understanding what's happening in space, how to make best uses of it, and engineering and finding solutions for space. So there's lots of options here. Do you have any other resources that you like to recommend for this topic? Our featured skill this month with Click to Science is enabling active STEM learning. And I was looking specifically for an activity out of these resources that would engage youth in solving problems and investigating phenomena, that it wasn't just a science or science inquiry activity or just an engineering activity, but a little bit of both. And for today's webinar, that led me to SciGirls, for an experience that includes a role model to engage youth in learning about what it's like to have a career in astronomy in particular. And it also includes strategies that can be used as an indoor activity or where youth can go out into their community to investigate a phenomenon that's in all of our communities across the world, and where they can develop real solutions that can be applied in their community. So that's the activity I'm going to be talking about today. It's called Star Power from SciGirls, but I know there are lots of other great resources that can be used for learning about space. So if there's anything I missed, please share those in the chat box. So I told you that this activity that I selected, Star Power, includes a video, and I want to start with that video. The video focuses on explaining the phenomena that I want to investigate with youth, and it's light pollution. So it'll tell you a little bit about what light pollution is and how it affects our ability to see what's happening in space. After the video, we're going to discuss how you could take the content that you see in that video and turn it into an active learning experience about space. So we're going to brainstorm different directions that active learning could go around this issue of light pollution. This isn't an activity that I do with youth where we watch a video and then brainstorm how we can investigate the content in the video. It is an effective learning strategy. It's just a very challenging one, and it's not something I would necessarily recommend for an after-school program that's just getting started with doing STEM. You might find yourself in a situation where you brainstorm with youth and they get really excited about an idea, but you have no idea how to pursue it. So instead, this is a strategy that I would recommend using with your staff. So you share a video like this with staff to get them excited about the theme that you're talking about, and then give them the opportunity to imagine where you could go with this and plan some of the activities for the summer. It gives them a chance to really be engaged in the process and excited about what they're going to be facilitating. So again, we're going to watch a video and then think about what different types of experiences we could provide youth to engage them in active learning about space or light pollution.
We really were looking forward to seeing all the stars. We decided to call Tina for help. So this is where Tina works? Yeah. Let's go in. Tina is our mentor in Science Club for Girls. Okay, so this is the last flight of stairs until we reach the roof. Oh, there's Tina! Hi, Tina! Hey, Tina!
Hi, ladies!
Tina is studying at Harvard, and she's getting her PhD in astrophysics. Yeah, we were out stargazing, and we couldn't see, like, any stars.
We're not that far away from the city right now. We're at the Harvard Astronomy Department, so the idea of problems with lights, exactly what you guys just said, is a big issue, right? I'm an astronomer. Yeah. I want to look up at the stars, and you guys couldn't see that many stars at all, right?
Yeah.
Having too many lights around prevents you from being able to see the stars up there. But light pollution is actually a really big environmental problem, not just for astronomers. There's a lot of inefficient lighting. So the different types of bulbs that we use, and then sometimes we lose a lot of light if it's pointing upwards rather than downwards, things like that. So that's just waste of energy. That's why we call it pollution, because it's actually affecting our environment, even though it may not be something tangible like chemicals into the water or something like that. When you're looking at the Earth from space, you'll see large pockets of light glowing from the cities. You can map out entire city areas and streets from space based on that. There are very few areas that are completely dark.
Whoa, look at that! The East Coast and the West Coast. They're so bright.
One of the big projects this year for the International Year of Astronomy is called the Great Worldwide Star Count.
The Great Worldwide Star Count? Oh, cool.
I'm really excited you guys came to me with this problem that you guys had.
So you basically count stars?
Yeah, the Great Worldwide Star Count, what it's trying to do is trying to measure light pollution by counting stars. So when you're at the park, you can only see the brightest stars. So the more faint stars you can see is actually a measure of light pollution.
We're not scientists, so how can we do this?
So we can figure out a method to quantify light pollution and do this Great Worldwide Star Count, and therefore we're scientists. You don't have to have a degree or anything to be a scientist. As far as I'm concerned, you're doing experiments and you're investigating things. That's the definition of a scientist. So the constellation that I've chosen to do for the Great Worldwide Star Count is the constellation of Cygnus, which is inside the Summer Triangle. So the Summer Triangle is made up of these three stars here. So there's Vega, there's Altair, and there's Deneb. And one of those stars is actually the tip of the constellation Cygnus. So when we talk about stars and how bright they are, we refer to a magnitude system. When we're going to be talking about light pollution, we're talking about a limiting magnitude. And everyone who's participating in the Great Worldwide Star Count will be using the same system. So if there's a lot of background light, some of these fainter stars in this constellation are not going to be visible. But say we can't see any stars except the brightest star, right? And one of the brightest stars in the sky is Vega. So that will be an example where light pollution is really bad. So this would be a limiting magnitude of 1. And then going onwards, other features become visible.
1, 2, 3, 4, 5, got it.
Eventually, so there's this interesting S-shaped pattern that happens in the middle of the cross. That too, if you can actually see that, then we're in good shape. And then, you know, you get to a point when you really can't, just too many stars to figure out anything.
All right, so hopefully you were able to see and hear that okay. And I see some ideas already being shared in the chat box. Thank you for doing that. You don't need to have a degree to be a scientist. That was a great comment from Tina there. What I'd like to have you think about is, where would you go with this? What are some investigations or activities that you might like to do with youth after having an experience, or based on the experiences you just saw? You wouldn't necessarily share that video with youth, or you could. So what could you explore? And the map at the top of your screen is a visual image of that idea that Tina shared about what the sky, or what the surface of the Earth looks like at night from space, how much light is visible emanating from the surface. You might see if you can think about where your local community fits on that map. Is it in one of the bright areas or in one of the dark areas? So the video we just saw here, where they're talking about what light pollution is based on the experience that the girls had in trying to observe stars in their local park, led to an experiment and some engagement in their community. So I will show you where this leads in this SciGirls episode that we're highlighting here, but there are a lot of different places you could start. You could start by looking at the level of light pollution in your own community, maybe trying to find your community on that map, doing some observations. Now, if you're looking at light pollution, particularly in the summer, that means you need to get out after dark with the kids, and that can be kind of challenging. So if that's not a direction that you want to go, the image at the bottom of your screen shows another way you could start, where you focus on an activity that you can do in the classroom that doesn't require going outside, or being able to see the night sky, which can be challenging for an after-school program. Another thing I wanted to highlight in the video we just watched is Tina is introduced as a role model. She's studying astronomy at Harvard, and she shares this idea that you don't have to have a degree to be a scientist. Everyone can be a scientist when they engage in the practices of science. And one of the thoughts I had as I watched this is Tina a role model that all the youth in your program could identify with? And I'd love to get some feedback from you in the chat box about this particular question, because I don't know the program that you're in, and whether that's something that you could see her being a role model for all the youth in your program, or whether some of the youth would have trouble seeing her as a role model. Again, when I share resources with the recording of the webinar, we'll share some of these ideas about where you can go with this activity and what you can do with youth. The citizen science project that they talked about in the video, the Great Star Count, was a one-time event, but there is a measuring light pollution ongoing investigation by darksky.org, which is the International Dark Sky Association, and they do a regular measurement of light pollution. So that is an activity that, if you wanted to take the citizen science approach to engaging youth with space, you could follow up with that activity. Thank you, Brittany, for the feedback. One of the things that you point out that is really useful in a role model is that they're engaging, that they're personable, they have an interesting personality, and that they are excited about what they're doing. And Tina does a good job expressing that in just the short clip that we saw. And if you look at the full 30-minute episode, you see a little bit more video of who Tina is and learn more about her and other role models also on the website. Okay, so I wanted to talk a little bit more about this particular activity, which is from SciGirls, called Star Power. And so here's just a little bit of a summary of what we're looking for in an active learning experience. I want to dig a bit more into what that skill is that we want to see staff have to be able to enable active learning in youth. And think about what it is, what active learning looks like, and what our staff need to be prepared to facilitate it. Successful active learning experiences are going to give youth opportunities to solve real-world problems. And we'll see an example of that in the Star Power activity. But it's an important thing to look for as you're searching for activities. Sometimes they're simulated problems. Sometimes they're a bit more remote, but being able to solve something that they can see as related to the real world is really important to engaging youth in after school in particular, because they're here for different purposes than when they go to the classroom, and they really do want to be working with the real world and real world problems in your program. The second thing you're going to look for in an active learning experience is that it allows youth to investigate phenomena in ways that are meaningful to them, to themselves personally, and to their community. So we're going to look for that in this activity as well. As staff plan active learning activities, they want to be sure and help youth make their own decisions about how they will pursue the activity, and know in advance what decisions are available that youth can make and what are the decisions that the program or the staff are going to make for them. So plan out what are those decisions that youth can make about the activity so that they have control of their learning. And we want staff to provide opportunities for youth to develop their own understanding of the phenomena. And we'll see how those 4 attributes come across in this particular activity. As we're getting into the idea of active learning, and particularly with your role as a trainer or coach, we want to think about the research that is behind these ideas. Understanding the research is an important part of what we try to support you in here at Click to Science. So this information I'm going to share for you comes from the 2012 framework for K-12 science education. And if you haven't looked at that before, you can search for it online. It's from the National Academies Press, and you can download the PDF of the framework for free and be able to access some really great resource about science learning from this resource. You can buy the book as well, but sometimes having the free resource is enough. So the first thing the framework helps us understand is that all science learning can be understood as a cultural accomplishment. Children and scientists explore their surroundings and think about the causes and consequences of the phenomena they observe in the context of their own experience and their own culture. What counts as learning and knowledge are closely tied to a community's values and what is useful in that community. So you want to think about how this science is situated within your community, and also realize that the culture that the youth you're working with bring to your program may be different than your own culture, and think about how science learning might be situated within their own cultural understanding, because science is essentially a cultural accomplishment. Second, the framework helps us understand that allowing science and science understanding to grow out of lived experiences, out of hands-on real-world experiences, helps remove the binary distinction between people who do science and people who don't do science. Just what Tina was talking about in the video. It diffuses this idea of being in science or being out of science, and it provides opportunity for multiple voices to be seen and heard in this field of science. So the idea is that by doing science, you are an insider in this field of science, and that's important for youth and for communities to understand that they are scientists, they are engaged in doing science, and it's one of the real power that we find in citizen science activities. The third point I want to make is that everyday experiences can provide a rich base of understanding that can support conceptual learning in science. Students bring their own cultural understanding to these experiences, and that understanding can be leveraged, combined with other concepts, and transformed into a conceptual understanding of science content and facts. Finally, learning science depends not only on the accumulation of facts and concepts, but also on the development of an identity as a competent learner in science with motivation and interest to learn more. And I think that's the real goal of science learning and after-school programs. It's not really about the accumulation of facts when we're doing science and after school, but it's really focusing on the development of identity as a competent learner of science with motivation and interest to learn more. If we can help the young people we're working with develop that sense of themselves as a learner of science, we're going to prepare them to be very successful as they continue to learn about the facts and concepts in the classroom and through other experiences. But it's really this sense of identity, I think, where after-school programs have the resources to make a real difference. We're about youth development. We understand young people and how to help them reach their full potential. And that's what we want to do through active STEM learning. One other resource that I want to share with you is one of the STEM teaching tools. And this one is STEM teaching tool number 19. Why should students learn to plan and carry out investigations in science and engineering? Now, I admit a lot of this particular one is focused on ecology, but exactly what we're planning on doing with space and looking at light pollution is very similar to doing an investigation in a wetlands, as you see here in this image. This resource, the STEM teaching tools, were created for teachers, but I think they also help staff at our after-school programs understand the skills of teaching STEM, and this one in particular focuses on facilitating active learning experiences where students have the opportunity through experience to construct their understanding of the world around them. This teaching tool helps us understand why active learning is important, how you can think about equity as you're facilitating active learning, and it provides specific recommendations for you to use as you're planning an activity like this. So you can search for STEM teaching tool number 19, and you can find it online, but it'll also be available as a download when we post the recording of this webinar. So you can go to the webinar, you can find these resources that we just talked about, and if you want to take part of this experience and do it with your own staff in your program, you'll have all the tools that you need there from that webinar to do that. All right, now we're ready to look at this activity, the Star Power activity. In supporting the activity itself, I'm also highlighting a PD resource from Click to Science called Making It Active, and again, you'll be able to download it. This resource helps staff reflect on what active learning looks like and use the Active STEM Learning Strategy List to examine an activity and redevelop that activity to encourage more active STEM learning. So we're going to kind of practice just a little bit of what that would look like. So you would take an activity like this, and if you're working directly with your staff, you'd want to print that out so they have it in front of them. For now, I'm just going to put it up on the screen for you to try to read on your tiny screens. And we're going to look at some of the points on the checklist and see how they fit with this star power activity. So the overall outline of the activity is, in part 1, youth design a constellation box. And there's kind of a picture of what that looks like down there. They're going to use that constellation box to project a constellation on the ceiling. And it's a cool way for them to have a project. They can use that in a lot of fun ways, but we're actually going to use it in our research in part 2, where we start investigating the idea of light pollution, and we're going to use the constellation box like they use the Cygna constellation in the video to evaluate what level of light pollution we have in our solution. Then in the extension of this activity, you would take youth out into their own neighborhood and look at the lights that are in their neighborhood at night and think about how they are contributing or limiting light pollution in their neighborhood. The part 2 and part 3 together gives youth the opportunity to develop their own solution to a real world problem and see how that problem affects the people and animals and energy use in their own community. As they go out into their community, they can think about how the solution they developed in part 2 might be able to make a difference in their local community. So in our next step, we're going to be looking at that part 2 where we're designing the solution to light pollution. But I wanted you to have an understanding of the overall project so that you can kind of see where that constellation box fits in and what we're going to do next. So here's the part 2 of that activity. Hopefully you can see that on your screen. And here are some questions to think about that you could use with staff to help them plan an active learning experience that they're preparing. We're thinking about how we can engage the young people in our program to work hands-on and minds-on with this star power activity. So we might start discussing together as a group what are some questions that learners might have about light pollution. The nice thing about starting with thinking about what questions the children will have is it also gives staff an opportunity to express the questions that they have themselves about this concept. We don't need to be able to answer all the questions that youth might have, but we should think about what those questions might be and get comfortable if there's questions that come up that we don't have answers to. How are we going to respond to that in a positive way, but not trying to answer a question we don't know the answer to? So we might say, I'm not sure. Where could you find the answer to that question? Or what resources do we have that might help us answer that question? So we want to think about what the questions are that learners might have and think about how we can respond to them, not necessarily giving them the answer, but encouraging them to find the answer for themselves. Next, we want to think about what are the materials that we could offer them to help explore this activity. Now, in the activity itself, the materials that you need for part 2 is a lamp and some aluminum foil, some heavy cardstock or lightweight cardboard. Cereal boxes work really well for that, duct tape or masking tape, and some scissors. So it's not a lot of materials that you need for this. So what might be some additional things that you could add? Now you might want to add some materials that wouldn't be particularly helpful, like some just regular paper. It's not going to block out a lot of light, but it gives them a chance to experience that and then think about what additional materials could they add. So having staff think about what are the things that they want to provide for youth, what are the materials that they need to provide is useful. It doesn't have to be a long discussion, but just get that out on the table. And similar with thinking about the space. What sort of space are we going to need for this activity? One of the things you need to be successful in this activity is you need to be able to turn the lights off and have it be safe. So you want a room where you can turn the lights off. That's probably not going to be your gym. but also where there's enough light when you turn the lights off that they can still see so that nobody's going to get hurt when the lights are off. So those are some things to think about. What would be the appropriate space for this activity? How much space do you need for each group to be able to explore the activity on their own? Are you going to have them working on the floor? Are you going to have tables? Some of those sort of things. And then you also want to think about how much time are you going to allow for that. Now, in the activity, part 1 and part 2 together are designed to take about 2 hours. So would you break that up over more than one day? Depends on how much time you have. Are you doing it for a all-day camp or a part-day camp or after school? So you want to think about how you're going to arrange your time. And are you going to give them a little bit more time or a little bit less time to work on this activity than what's recommended? Depending on your goals, you're going to adjust that. Finally, we want to think about what questions we could use to encourage active learning and problem solving. And it's really useful to actually brainstorm those questions with staff and write them down so that they have the questions with them. And I would have them write them right on the activity that they're going to be using when they lead the activity. So those questions are right in front of them as they're leading the activity. And then you can think about what are you going to do next to build on the learning. Are you going to move on to another experience or topic that builds on this understanding? Are you going to go out in the community and have them apply what they've learned? Are you going to move on to a different issue that maybe is moving on from exploring light to exploring distances in space? There's a lot of different directions you could go, but it's helpful to think about how you connect from this activity to the one that's coming next. And maybe the connection is about solving problems, not about the content itself, but knowing what that connection is really important. All right. That's kind of an overview of how you can help prepare your staff to use an activity like this to build STEM understanding and to help youth engage in active learning. I want you to know that you can do this in your program. You can explore resources from NASA and the other sites we talked about to engage youth in active learning. You can plan connections between the activities that you're doing over the course of your theme that build upon one another. As I said, the connections can be related to the content, building and developing, or you can be connecting and focusing on the skills and applying problem-solving skills and developing their engineering and problem-solving skills over the course of a series of activities. You can use professional development resources like Make It Active that you find at Click to Science to help prepare staff to use these skills with the youth in your program. And then you can adapt and extend activities with real-world problem solving and application. And these are the strategies that you can use to make active learning part of the culture and the purpose of your after-school program. Here's the big idea that I want you to take away from our webinar today. There are lots of great resources out there that you can use to make learning about space fun. But we also want to make it hands-on and minds-on and engaging youth so that they see themselves, as we talked about before, as someone who is a competent learner of science with motivation and interest to learn more. That's the biggest opportunity we can provide to the youth in our program, that we can give them the skills that they can take away so that they can learn more about science. This is my contact information. If you have any questions on this content or would like to learn more about Click to Science and the resources that we have, please feel free to contact me.